Welcome to Tuners Subaru Training Part 12. In this tutorial, we're going to take a look at the mass airflow closed-loop fuel calibration tuning process. We're going to look at what tables we need to go in and focus on within our VCM editor software, and then what we need to data log, and then going through the data, how we can actually make the update changes into our mass airflow table based on our closed-loop fuel trims. We have a lot to talk about here. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at how we can use our closed-loop fuel trims to help us recalibrate our mass airflow calibration curve if we've changed the intake from stock to an aftermarket unit. Now, the vehicle I'm sitting in right now has a Cobb SF intake. We're going to learn how to recalibrate this using our log data through the VCM scanner. It's actually a really simple and straightforward process. There are going to be some things that we need to know in order to rescale our MAF curve to get a good starting point, and then to go through and then shape the MAF curve based on, again, our log data. Let's jump in and talk about our mass airflow curve. We're just going to do a quick refresher. We've talked about this in previous tutorials, but we're going to make sure we understand exactly what's going on here in this tutorial as we go through and watch this calibration process. So the very first thing, I have a stock MAF equivalent file open. This is basically a stock file. I'm going to go in here into the engine section, and then under airflow, we have our MAF calibration curve right here. Now, the first thing I want to do in my calibration curve, because I'm dealing with a larger than stock intake and I'm going to be turning up the boost, I want to make sure that this maximum grams per second of airflow registration is turned up. I'm going to change this from 300 to 500, and then I am going to go in here to the load limit and change this to 20 grams per rev, just so this is not going to limit me in the calculations that are going on with the mass airflow sensor. Now, I don't anticipate with a stock turbo ever touching these limits, but it's important that we start to raise the thresholds of limits up so they don't become a hindrance at some point in time. Now, if you have a larger than stock turbo, these could become a problem, so we want to change them. Just get in the habit of updating your values right here. Now, the next thing we need to do is jump into the MAF calibration curve. This is the calibration curve for a stock airbox stock intake setup. Specifically, where the mass airflow sensor is housed is the MAF housing size. That is the equivalent of the stock MAF housing size, this calibration curve right here. This is what Subaru has figured out to run a stock engine with a stock intake, and we'll find this is translating the amount of voltage output from the sensor as the airflow is passing over the sensor to look up what the amount of air mass determination is going to be. It's a direct lookup here. So looking at something like 2 volts, we can see here it's 19.18 grams per second worth of airflow. We're going to find if we change the intake out to larger than stock diameter, so Cobb SF intake here, for example, is larger than stock. The intake size being larger allows us to move more air into the turbo, into the engine. It makes things more efficient, and we do pick up some power by having the intake installed. As a result of the larger than stock intake size, specifically the MAF housing size is larger than stock, that's going to be throwing off this calibration here between the voltage to the amount of air mass moving into the engine. Specifically, the curve will have to move upwards, so I actually have to shift this up a certain percentage to get started with here. So for example, at 1.8 volts, we're not going to be flowing 2.49 grams per second with a larger than stock MAF housing or intake size. This might be at something like 16, 18, 20 grams per second, depending on how large that size is going to be. We need to go and perform the rescale right off the bat based on our new intake size, specifically the MAF housing size itself. Let's jump in and take a look at the Excel spreadsheet calculator so we can go in and calculate this pretty quickly. We don't have to go through and run through a whole bunch of math equations in the background. It is not going to be as simple as just measuring the difference between one intake and the next, or the MAF housing size. So stock, we're going to know, and then the larger than stock MAF housing size. It's not going to be just measuring the difference and figuring out that mathematically. There's actually a lot more math crunching that has to go on. The Excel spreadsheet is going to make this very, very simple and straightforward. Let's go and take a look at the spreadsheet here so we can start to watch what happens here when we recalibrate our curve. If I jump into the Excel spreadsheet, the very first tab is called MAF Rescale. This is going to be taking a look at a couple different parameters here up top we need to go account for. We're going to find that we have a stock equivalent MAF curve here. This is labeled stock. This is going to be our voltage range for a stock MAF. And then these are the associated flow amounts in grams per second with a stock MAF curve. Now, important here, if you're coming in with a STI or a WRX application here, doing your calibrating and tuning, these values should be what you find in your stock MAF calibration curve. If for some reason, if you're comparing these values to the values here from your calibration file, if you're finding that they're different, well then make sure.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.